Welcome everyone on the developers meeting on 1st of June. And we are going to see a demo by Carlos. And I now switch over and hand over to Carlos. Carlos, it's yours.
So yeah, what I thought I'll do is just go through the basically the GitHub that we have. So this is not switched on. Let me check. Yeah, I need to do it on the other side. But basically, it's just to go through Aloha and just show yeah, what we have on the on our GitHub. And so basically, right now we have just a basic structure. Then we have the initial documentation in here. And then we have the software architecture, already some topics here. And I can click on them on the side. And yes, we also have some that are still hidden, so software architecture. But you can see they are going to link inside so that we see them, the files here for the documentation. We have the source where we're going to have the different parts of the code. Right now, the only thing we have is the ECAL code, where we have the basically here we have examples of how to use it. So this webcam is going to play from the normal USB camera that you can plug in, and then this is going to broadcast through ECAL. And then we have a viewer as well. We have a recorder and a player. Uh, the recorder and the player I need to update because they are recording and playing from a folder based on Windows. So I need to update this for our purpose. And then in here we have basically utils, which is just creating nodes for us to easily include and use. If we go through the documentation, so in the software architecture, for now we have the folder structure, what we were discussing just to plan out how it would be. And so the idea is going to have, so these scripts are going to allow us to just create um, different things. So for now, we have a script there that it's going to build the bindings for the proto buffers. But yeah, we're going to have different scripts in there. In contrib, we're going to have everything that is external. So we have the wheel that was created for ECAL. We have the SDK. So right now I've put there a file that is empty. Just created that as an example. Then later on, if we have different libraries that we want to include, for example, here we've put the Bob tracker, but we can include here as submodules so they can stay here and you can use them. Um, then on the source, we're going to have background subtractor, if we have camera calibration and things like that. So these are going to be the folder structures. Then ecal, image processing, if we have any, ROS, utils, things like that. The issue with the way things are included in Python, we need to be careful uh, because we need to have at level before so that we include. Otherwise, we need to do some gymnastics with includes, and it's not nice. But yeah, so then we can have specific implementations for specific platforms. So we can separate for the Orange, we can separate for PC, and if we have later on a web page as well with a database that we can have, so we can also have implementations for it. The key thing is that, for example, from PC and from the Orange, we're probably going to use things from the source, so things like ecal and so on. It's going to be common for both, so it's good to have them as a package. And then here we also have already tools, so there are some camera tools. These camera tools are for USB type of cameras for now. So what they do is to calibrate the color and things like that. So it's just helpful tools. And then there's multicast tools as well. So later on, when we plug in different oranges together, they need to communicate between each other, and so yeah, so these tools are to help that. Um, then we have the documentation here. So basically, for now, it's just getting started and how to set up the environment. And so basically, just go through it. Things like the GitHub as well, how to configure it. You can get your email and everything. Then we have OpenCV if it's needed. Um, it's good to have the OpenCV in C++ because there are some dependencies on it. So that's why I'm installing here the C++ version. Um, yeah, some links that we need, and then also Conda environment. So the idea of having we can have if we have a single environment, we can just install everything, Python and all of that. But Conda allows us to package the environment that we need, so that it's easier for us to set up. Yeah, so here I'm just explaining how to install Conda. And then from here we have setting ECAL. And so this is what I've shared before, but it's just to put here. Um, so yeah, so we need to set up ECAL. Now, ECAL has two points. One is once we install through the package, so this is going to install a library or a set of applications. So if we go here, you have the launcher, you have the monitor, player, and recorder, and also a system. And so these we have these applications here that we can use, and also installs everything that is needed for C++. So that's what the first part is going to do. Now, when we get to the Python version, we need to have the binding. Um, and so we need to have this wheel for the orange. Uh, Online, they have a binding for Windows. They have binding for Linux as well, for Ubuntu. So if we're using on a PC, that's fine. But then anything else, we need to build a specific.
Carlos, sorry, may I interrupt? Can you just shortly explain to us what the wheel is and what it helps? I never heard about this.
Yeah. So basically, when we install a package in Python, you can do pip install and install the package. Um, but if it's not coming directly from the install, then you can install using what is called the wheel. So it's like it's a setup, let's say, for packages. And so that's what we have. So when we go to ECAL web page, we can download the wheel and then install that on our Python. It's good to use in Python. And
Okay.
so as I was saying, they have the wheel, the installer for Windows and for Ubuntu, but they don't have for the Orange. And so I had to rebuild it, basically build the entire setup for ECAL, and then generate the wheel. And now we have the wheel in the source, and then you have the contrib, and then you have the wheel here, so you can just use it.
Mhm.
Okay. So in this step, once you create your environment, you activate basically the environment, and then you just pip install and install from the source and install the wheel directly.
So it's
Um,
actually, sorry, so it's actually the wheel is a package with an API for ecal.
yes, yeah, for the Python version of
Yeah,
eCal,
for the Python.
for the
Okay.
binding. Yeah,
Okay, got
yeah.
it.
So if we don't have the wheel, then I'm going to have as well just a explanation on how to generate the wheel, so that later on, if someone goes into trouble and has to do it, so it's already here. But yeah, so if you have an orange and you're using the orange, just install straight from the wheel that is here, and you're good to go. And then we have examples. So we have this LO ECAL that is just going to run the examples basically. So we activated the environment, and then we test the recording and the sender, and we can see it. And yeah, we can do this. So I can open two terminals. Yeah, so they are here. So I'm already in Aurora. So we need to go to the source. Where is it? Yeah, so this is the structure that we have. So we go to SRC, and then we go to ecal, and then here you see that we have the test send and also test receive, which are the examples that we have here. So we need to, in my case, I already set up the environment, so I can just do conda activate Sky. I need to write. I'm writing everything here, just for explanation, but I have alias. So, and it's a problem because sometimes I don't remember the actual commands because I just, for example, in this case, I write to go sky and go straight to it. But yeah, so here I activated the sky, and I can do Python test and recording. And so this, sorry, I was saying record. This is the receiver, so this is going to receive what we want. I can probably move this to, no, probably not. Let me just open a new one. It's better to see. Yeah. And so the same thing, we need to go to Sky, no, to ROS and see the SRC, and then ecal, and then the same thing. So so I'm in there, and then this we have the test. In this case, I'm going to activate the sender, and so the sender is just going to ask for a name, and then we can just send messages, and we can press Q just to exit. But yeah, once we send a message, we see that is on the other side. So if we go to the monitor, we see the decal monitor, and we see that we have two processes already on the orange. So it's a sender and a receiver. We can click here and see if there's some messages coming through. So in this case, because it's waiting for me to put an input, it doesn't show anything. If it was something playing, then it will just play as it goes. So yeah, we can see from here that is running. Another thing as well is that we can do a recording. So basically, here we could set up the where it's going to save the recording, and then just press record. But I'm going to show the example later, because so yeah, we can press Q here. So this exits in here and also on the other side. So the other example that we have here is to work with cameras. And so it's in the same place where we were before. We can open the tool. I don't need it, but and so this is going to be the webcam. You can configure actually I can do .h. So yeah, so once you do .h, it's going to tell you what are the fields that we can have. So we can have the channel name, we can have the camera ID, and this camera ID, because this example or this webcam to ECAL is based on USB cameras. So this is using the same ID that you would use for OpenCV. So in OpenCV, when you open, you have multi cameras connected. You can select between each camera using an ID, and this is exactly the same. And then message name and the proto file. But usually these are just common for this type of application. So later on, when we develop the interface for the camera that we're using, we're going to have its own message type and its own profile proto file as well. And so in this case, because I have just one camera connected, then I can just run the camera. And so, yeah, this is overexposed, but get the idea. Yeah, so we have the fisheye just in there, and it's just propagating. Now, if I go, do I have it still open to the monitor? You can see that the camera is playing in here, and we can play and we see what is coming out. An interesting thing as well is that we can define, if we want to go to the trouble, but we can define our own plugins for this software. So we could have a plugin that will just allow us to visualize the image. I need to check online if they have any or not. So the other part, which I can put it in here, is the visualizer in here. So this is going to view the camera call, and because everything is configured automatically, so it's the same thing. So this viewer is going to subscribe to the same topic as the player, and then we see the results in here. Um, and now if we go to the monitor, we see that now we also have the viewer in here because it's also a node that is going to be playing online. And if the broadcast was set up, I could also see it on the Windows side as well. Um, yeah, so I can close the. Actually, I had already two monitors. This doesn't show the screen. Yeah, so I have the two. I'm going to close the viewer for now. And so right now I just have the camera playing, and I'm going to record. So you can see the path where it's going to record. So configurations here, we can say that we want size of the file. So in this case, I'm just going to put 500. So for us to see the effect. And if we have more things running in here, then we could have select this so that we have one file per topic. So if we have the three cameras running, the recorder would record each camera on its own file, so it will be separate. But in this case, I just have one camera, so that's the only thing that we're going to record. So when we press recording, this is going to record the feed from the camera. So can I copy this? Oh, yeah, I can just go there. So this is home, ECAL measurements. Yeah, it's putting it in the SD card. And you see that it's recording in here. And inside the orange, then you see the file. So there's the first file. Now, because I've put just 500 megabytes, so it's just breaking it up in different files. So the way HDF files are created, they are based uh, on timestamp. So later on, if we want to just take a part where we identify, for example, a detection, then we can look at the timestamp when that happened, and we can just share the file that contains this. And ECAL is just able to run, for example, this single file straight on. So there's we can break it. And if we take alternate files, so from here to here, it's going to run this file first, and then it's going to wait for the time because it's going to play it synchronously if it was there. But it plays both files and doesn't complain about it. So yeah, so we've played this. I can stop it. So I can also get out of this. Yeah, so it gets out. Now what I'm going to do is the other way around. So I'm going to open the the view, which is here, and I'm going to open the player. So now if I open measurement and physical measurement. So when I open the measurement, it's here. So this is the recording that I did. And when we play, and it's just going to play as if it was real time. So it replays everything. Yeah. So what else? Yeah. So this is just a brief introduction about ECAL.
May I have some questions. Maybe
Mhm.
ask them now because you're right in this. Um,
Yeah.
so when we use, let's say, the camera controller together with the tracker, whatever the tracker will be,
Hmm.
and we run both on the same system.
Yeah.
I mean, I understand that it makes sense to share this over several boards, but if it runs on the same system, won't you say that shared memory is faster than ECO or ROS?
No, so that's the benefit of ECAL. So I'm going to push as well another document on it.
Uh-huh.
So the benefit of ECAL is that if the two things are local, so they are going to share memory. So there's no Ethernet connection.
So
So
ECAL is doing the
in
shared memory stuff.
yes, yeah.
I
So in this
see.
case, I have two nodes. One is the player, and the other is the visualization, and they are just sharing using shared memory. So there's no other allocations or anything. So it's just shared memory.
Mhm.
The
And
benefit, yeah, sorry.
now go ahead. Benefit is?
No, is in ROS you have shared memory as well. So you have two nodes and they communicate between them with shared memory. Now they added also the option of communicating through Ethernet, but you need to switch. So you need to specify directly the communication, and you need to switch. Whereas ECAL, no. So ECAL, this is playing. I have the other node viewing in this example. If I connect with my Windows PC, then it's just going to get the message from there, and I'm able to see on Windows. When I switch off the Windows, then it just switches off the UDP communication. So ECAL does everything automatically.
But if it's both on the same computer, and so I do not have to mingle with shared memories. I just have to integrate ECAL and
Hmm.
a proto and publish this via the proto file.
Yeah, yeah. So
And
this works exactly like ROS. So then it's going to be a node subscriber publisher
yeah,
type of nodes
yeah.
and the message.
Okay. So on the one hand, I have the camera controller, which is still working with shared memory. So I have to take out the shared memory stuff, and you have to help me with the ecal integration. I never did this.
Yeah, yeah. I
Um,
can do. That's my plan is to do the decal interface next.
okay. So in this case, we don't need the shared memory stuff anymore.
No. The only thing is if you have a buffer or something like that, yeah, then it should be the buffer should be inside, let's say, the function that is going to need it. So we need to have a management for that, if it makes sense. Yeah.
Now, yeah, but what I would say is we have two buffers. So one is the frame data and one is the metadata. And we also need to propagate the current index in the buffer, the buffer index.
Mhm.
Is
Yeah,
this
so that now is going to be done through ECAL. We just
okay? All three.
publish everything
Okay.
through ECAL.
Hmm.
Yes.
So this means on
And
the
what
other.
I would suggest,
Sorry, go ahead.
I was saying what I was suggesting before was to have different protobufs. So you have
Mm.
a channel that is just going to send the camera. You have a channel that is going to get the inputs to the camera, like configurations that we need.
Mhm.
We're going to have something that is going to send like signals for us to monitor, see if it's blocked or things like that. And then also other stuff that we need can also be sent independent.
Mhm. Okay. So in this case, I have to remove all the shared memory stuff also from the viewer and the other
But
scripts that use the camera, the
I
buffers.
was looking at the script as well. There's parts of it that are needed, isn't it, from the camera side? What I mean is that you have that training in the beginning or learning in the beginning. I don't know where it's the controller.
This one.
Um, so yeah, so the ring buffer is also I think it's needed for the autofocus, isn't it?
No, there's no autofocus. It's the auto exposure. But the ring buffer
Oh,
is,
sorry, auto exposure. Yeah.
yeah. So there are three classes. One is the camera class, the controller itself. One is
Mm.
the ring buffer, and one is the auto exposure.
Yeah.
And
You were
the ring
talking about this buffer, isn't it? When you
the
said
ring
buffering.
buffer. Scroll up, scroll
Yeah.
up. Yeah, here it is. Now, yeah, go ahead. Yeah, here it
Yeah. So
is.
the
The
ring
ring
buffer
buffer.
here.
Yeah, exactly. So like I created shared memories to use them with other scripts. So I don't need this anymore. And this stuff needs to be somehow configured into the protobufs.
Yeah.
Okay.
So also that's why then we have the main here. Um, so the main works as an example.
Mhm.
The functionality here now is pretty much the same as we have if we were plugging in an OpenCV camera. So we're just capturing it. Um, so it's pretty much the same. So now I can just wrap it up basically an ECAL node on top of this.
Mhm. Okay. And the ecal node is propagating the current frame content or so.
Yes, yeah.
Okay.
So, like I said, the idea would be to have a channel which is just going to propagate the frame, and we can have other parameters in there, like size of the frame and things like that.
Yeah.
Then we would have another channel which is going to be diagnostic type of information.
Mhm.
So all these logs, I would convert them into a log that is
Mhm.
going to be propagated in its own channel,
Mhm. Mhm.
so that we can debug outside.
Mhm.
And then from the list of parameters, that's what I was asking as well, just to make sure because now they are as constants here,
Mhm.
but to see which ones we can actually use for configuration, and they
Yeah.
can be an input,
Yeah.
and that can be a channel as well.
Yeah. Yeah. So there's several ones, not all of them. Several ones are
Mhm.
meant for controlling. Yeah.
Yeah.
Okay. Yeah, I'm struggling with the ecal stuff. I've never done this, so I need your help in this.
Yeah. Yeah, and also I want to do some examples also for ROS because there's some parts where more on the control side. for example, for the PTF, those kinds of things, ROS are better for
Mm-hmm.
control.
Mm-hmm.
So I want to set up some examples as well. Have a markdown explaining how to install and configure everything.
Mm-hmm.
Um, yeah.
Yeah,
Another
cool.
benefit of ECAL, as opposed to ROS, is that ROS is designed for Ubuntu, for PC. So there's no implementation for Windows, for example, or other operating systems. So if we want to have, for example, something to monitor, yeah, it's a lot difficult to use ROS, but yeah, that's one of the drawbacks.
What about ROS Bridge and doing it via a web interface?
Yeah, we can have that as well. I need to try. I was reading online as well. I think we also need to do the same thing I did with the ICAO for us. We need to rebuild for Orange, but that's something that I need to check.
Okay.
Um, yeah.
Mm-hmm. Um, One thing you demoed was the monitor. The monitor is a standard ECAL monitor, right? Where you can
Yes.
define
Yeah.
what to subscribe, where, which node, and so on. Okay.
But the idea is to have our own monitor. So even I was showing the player.
Mm-hmm.
But for example, if we go here, we have a player script as well.
Mm-hmm.
Because it's more flexible. If we have the code, then we can just play it.
Yeah.
Same thing for recorder. So the idea would be to have recorder nodes that we just trigger and they run. So you don't need to have the recorder in there. So this would be better.
Mm-hmm.
Um, and then we can have a PC version monitor. So if you have your PC, you can plug into the same network, and then you can listen to what it's going on, see if something is broken or yeah,
Mm-hmm.
just to monitor everything.
Mm-hmm. Okay, so the monitor you showed us is more a developer tool where you can see
Mhm. Yeah,
everything that is where you can subscribe to. Okay.
yeah, from ECAL itself.
For the question is, if we, because not everyone has a PC, some people have other devices, whatever. Our
Hmm.
idea was to have everything in a web front, in a web
Yeah,
interface. Um, and if we, in this case, if it's in a web interface, then we would need a node that transforms all data into something presentable in a web browser.
yeah. So
If
that's why I think we should have also a database that can be running
Yeah,
on an Orange.
yeah.
But yeah, having a database in there.
Mhm,
And there's some parts like the detections and things like that that we can just log in the database and be accessible from other nodes, for example. So there's benefits in having a database in
mhm,
there integrated in the architecture.
mhm. Definitely.
Yeah.
Yeah.
Just wanted to share another thing as well. So this is the ECAL monitor on my PC. And you can see that the orange is broadcasting and everything. So now if I wanted to have a view node, I could just check on PC as well and visualize from the PC. So yeah, because basically it's connecting, the multicast is activated within them.
Mhm, mhm.
Yeah. And
Um,
so if you have your PC, you connect to the network that is being used by all the oranges, and then you can see at the moment with the monitor.
mhm. You have a setup where you have a web camera, a USB camera, let's say,
Hmm.
um,
Yeah.
and you run it with HD format and 30 frames per second, something like this, right? And have you done this over the network to have it on your PC, the playback of it? And if it
Yes,
works,
yeah.
what is the delay in frames with the 30 frames per second? Can you give an idea?
Yeah, so basically, I'm able to run the camera at 30 frames per second on the orange. I thought, is it running at the moment? And there's a delay, so then I get around 20 frames per second or something like that. I've pushed for it, so I have two PCs running, each one with its own camera and another camera on the orange, and I had the three broadcasting and subscribing, and then that lowers, so it's around 10 frames per second in all of them.
Mhm,
So the more things we put in, the more demanding it's going to be.
mhm.
But it is. Um,
But
I don't know
if the fisheye sorry, but if the fisheye camera only runs on 7 frames per second, would you agree that the on the network on the monitor side you would get all 7 frames per second, or would we also lose some?
it should be also 7 frames per second. The main question that we're going to have as well is the frame, the dimensions of the frame, right? Because it's going to be big frames.
Yeah.
So that might be an issue with the amount of data, but typically it should be okay. Yeah,
Can you
if we
try
push
this?
to,
Yeah, sorry, can you try this with your camera? If it's not
uh,
3200 by 3200, you could um, rescale it to 3200 square.
I can try that offline. But yeah, I
Yeah,
need to
not
try it
now, of course.
offline.
Yeah, yeah, not now,
Yes,
of
yeah,
course.
but I can try it. Yeah, so I can use my Canon as well, so that would be a good reference.
Okay,
Yeah.
all right. Yo. Okay, so one last thing I wanted to know on my note list here is what is, I know what Conda does on Windows, but what does Conda on Linux? Why do you use Conda on Linux?
So in both basically, but so you can have there's different layers. So you can have a virtual machine. So that's going to be you install operating system in it, and you do it there. Then there's the other layer, which is like a Docker container, where you have a container, but then you set up the environment parts that are from the operating system. And the next layer is going to be an environment like Conda, and there's alternatives as well. And in there, you just create what is needed for your project. So then you have the packages that are needed and all of that, and they are
Oh,
contained in there.
okay. So in this case, it's a pendant to Docker, you could say.
It's the level below Docker. So Docker also installs things related with the operating system, whereas Conda just installs things that are related to the project. So
Mhm.
things that are packages that are included and things like that.
Mm, I get it. So when you remove
Yeah.
Conda, you also remove the complete environment.
Yes. Yeah.
Uh-huh. Okay. Yeah, I term it for it's a tool for developers, right? It's
Yes.
not
Yeah.
something we need for the final system, right?
It might help. It might help just to have everything contained, because if something breaks, um, then you have. I think my orange is blocked. But I was going to show that you have the requirements, so things that we need to install. And so if something goes wrong, you just install from the requirements, and you have everything set up. So it's a lot faster to set up everything, I would say. So that's a benefit of that.
Okay, okay. So we had a lot of discussions about Docker in the past, and I think if I recall correctly, a lot of things is it's not 100% on the CPU. There's an overhead somewhere. it is said. I'm just saying what I think I can recall. Please correct me if I'm
Mm.
wrong. So there's a CPU percentage we had to cut off, and Docker has some issues with drivers via USB, for example. So we had problems to get the camera running on Docker. Um, would it be an issue with Conda?
No, no. And Docker is more, again, it's also a development tool. I think Docker would be interesting if we want for developers, like someone working on PC, on
Mhm.
Windows, to simulate what's going on inside the orange without actually having a physical orange. So then yeah, we could create the environment on Docker, and they would compile and build everything and work on Docker.
Mm,
But I think for our application doesn't make sense.
right.
Um, from Conda point of view, it's just an environment. So instead, in your system, you're doing pip install the packages, and this is installing in your operating system. Um, so the alternative is that you have the Conda, and then Conda is just packaging everything in the same. So later on, if you delete the environment, it just cleans up everything from the system, so it doesn't populate the system.
Okay. Yeah, but it feels to me it's a tool for developers. But my question is, do we
Yeah.
need this in the final system? I assume
No, so
no. Okay.
you can do, yeah, can do pip install in the system as well.
No,
Yeah,
sorry, Carlos. Maybe I turned my question wrong. Um, the final version is something where we just publish images for SD cards, and
mm,
this image contains an operating system, of course, and certainly with a lot of installed libraries and environments, what have you, and scripts, of course. But
yeah.
would you see Conda also in such image, or is Conda just something that helps during development?
It helps during development,
Yeah.
so it doesn't need to be in the final system.
Okay.
Um,
So
yeah.
and Conda is not the tool that creates such an image.
Um, I was going to open this when yeah, my orange is blocked, but basically this is the environment is created anyway, so you have a single environment
Mhm.
at the moment. But when you install Conda, it allows you to have multiple environments at the same time. And if you just use as a single environment, you can make a backup of it. You can delete it and reinstall again, so it's more flexible because of that. If you want to back up the without Conda, you need to go through and figure out where the packages are, and it's more difficult. Whereas this puts just in a single folder, and it's there, so it's simpler.
Okay. So instead of, for example, instead of creating an image from scratch, installing the operating system, installing on libraries and what have you, we could just have a Conda environment and just install a fresh operating system, for example, put this Conda environment on the operating system and create an image, and we're done.
Yes,
Is this a
yeah.
process that works?
Um, but this is just for development, for the development environment. So
No, I mean
if
for
we're
the.
talking about like, yeah, for a system, we still need to do a copy of the operating system. Yeah, copy of the SD card. We still need to do that. This is just for development.
Yeah. Okay. Okay.
Yeah, so it's the packages that are needed
Mhm.
for Python and everything. So they are in there.
Okay.
So for example, the wheel that we installed for ECAL, I installed it inside of the Conda environment, and so it's there.
Mhm.
I don't need to do anything else.
Mhm. Okay. I think I understood it. but I still have to digest. Okay. Um, it's 1 hour now. Are you done with your demo, or is there something you want to add on?
Yeah, I wanted to share as well
Mm-hmm.
on the other side. Basically, we have s- going back here. Um, yeah, I've just pushed this document in here, so I can create now the pull request, and I put it here. So this is just a documentation comparing ROS and ECAL and an introduction on it. But what I wanted to show, so we have a problem that we probably should fix. So I should not be allowed to merge my own code. So I think we should have always a reviewer. So in this case, I can put you as a reviewer. But we should at least have one reviewer, and the reviewer should be the one allowed to merge the pull request. And this is something that we can later on do in the configurations. Um, but what I wanted to show is once we have the pull requests, then we can review, and then we can set up this. I like having the two planes
Mm-hmm.
where on this side
The
it's
changes.
just the part the changes that we have.
Mm-hmm.
And so then another thing that I wanted to say is that, for example, in here, then we can just leave a comment for the review, and also we can make suggestions. When you click from the suggestion, so if it's something quick, then we can make the suggestion, and then it's just when we're correcting it, we can just apply.
Mm-hmm.
So it's easier to do the reviews.
Mm-hmm.
Um, but yeah, it's just about this. Um, Apart from that, I think I don't know if you have any questions also in here or not. Um, oh yeah, there's another thing as well. Is I don't know if you've seen the projects here. So this is if we want to have planning. So they have we have they can have Kanban as well, so that we have defined tasks,
Mm-hmm.
and then we can just move the tasks as we do them. We can also have a roadmap, and you can have the tasks then in basically in a spreadsheet that we can use. So yeah, to manage the projects as well. This is
It
I
is
don't know if you want to use.
that's what I never understood. Aloha is a repository, and projects is a sub under Aloha. Does that mean
Yeah.
that is it meant to have several projects under one repository?
No, this is the name that they gave to it. Just call it projects. But if you create, I think I can create. You can then delete if you want. Um, but if we create a project, what the only thing you're going to have is basically the tasks in the spreadsheet.
Mhm.
Then you have the roadmap, and then you have the basically the Kanban. So that's the three things that it creates, and it creates for Aloha, but then for other repositories, you're also going to have the same thing. It's just the name that they created.
Okay, so projects is not how you say this, not a sibling to Aloha.
This is part. It's just a management framework
Yeah.
now attached to Aloha.
It is well attached to Aloha. I get it.
Yeah.
Okay. So when
Yes.
you create a project number one here and you go to another repository, you wouldn't see project number one there, right?
No. No. No.
Okay. Okay.
No. And
So
then
if
benefit of this is that you can create tasks, and then when you do the pull requests, you can link between them, and then you're able to see the progress and all of that. If you want to manage the project, let's say.
yeah. So when you say the project, it sounds to me like you mean the Aloha project right now. Or do you have other projects in your mind?
N- No, it's the name that they gave. Basically, it's like Teams in Microsoft. They call it Teams, but it's so it's the name that they gave to the interface.
I see. Okay. So
Yeah.
projects is just a stupid naming. meaning
Yeah,
something that's
it's
actually
yeah,
not meant to be. Okay. Ah, okay.
it's like Artisan. They have Jira to do the agile. So here they call it projects.
Okay. Okay. So if we now click on new project and how would you call it?
Yeah, I can click. I think it's going to call the same. Yeah, you have the template, and then you can select what is going to be. Um, but yeah, so you have different types of backends for projects. But you can see that it's so this is Kanban project. So this is a agile framework.
Mm-hmm.
You can have the tasks defined in here. I don't know if they have an example or yeah. So this is the roadmap.
Mm-hmm.
So it's just like a Gantt chart that you have.
Mm-hmm.
Yeah, and then you have also the retrospectives and things like that.
Mm-hmm.
So this is just an environment. It's equivalent to Jira. I don't know if you ever use
Never
Jira
used, but
for multi.
I get the idea. I know what it is.
Yeah.
What would you propose? Iterative or roadmap or Kanban or
They are connected, so you can add them there. So you can have them all set.
okay, so
The
it's not
Kanban,
a
the
choose.
Kanban, yeah.
Yeah, it's not you have to choose now one of the templates.
I think that's why they put the S in the project. So when they call projects is basically this. But yeah, you can.
Okay,
So
okay,
you're going to have a tab there, and then in the tab you're going to put all of them.
okay.
So ideally, you can have the board, which is going to be the Kanban board, and then the roadmap is a Gantt chart, so that you have visibility on what it wants. And
Mm-hmm,
the three are linked with the table, and the table is just a table of tasks.
mm-hmm.
Yeah, so that's basically it. I don't know if there was also a bug tracker in here. I don't know if it has anything specific, but it's Kanban as well, so I think it's going to be the same. It's just probably a different visualization of the Kanban.
Yeah, yeah, okay.
Yeah,
Okay, so
yeah.
let's click it. Let's create this project.
We can do this offline probably. I
Okay,
think it's better. Might take a little bit of time
okay,
to set it up. Yeah.
okay. Yeah, we need to set up some other stuff as well. The reviewing stuff
Hmm.
as well. Okay. One stupid question from a Git noob. I have a local branch and I call it a lower branch. If I commit it, I have the Aloha branch on GitHub. Then, is it right? I'm just asking if this is the right way that I should do. Then I create a pull request so that from my branch on GitHub, the stuff is integrated into the main.
Hmm.
Is this the right way to do? So branch to branch, and then from branch via pull request into main. Or is this wrong?
Yeah, so that's the correct way of doing it. We create a branch that we will work on our local machine, and then we push that branch. Once we push, then it asks us to create the pull request. Then someone reviews the pull request
Yeah.
and merges. And when it's merged, then it's merged on top of master or main. In our case, it's called main. And so then it's merged, and then on your local machine you get main again, and you work on top of main.
Why do I get main again? This is confusing for me. Sorry, guys, that I asked those stupid questions. I'm really a noob to Git. Um, if I have a local branch and I think my code is in this local branch, yeah, let's say, and I commit this, it becomes the same branch, but on GitHub. And then I integrate
Mhm.
it via a pull request into main. Next step is I need to update main back into my local branch. Is this right?
Mm. Yeah, yeah.
Okay.
Yeah,
So
so it's just that if it was production code, typically we have the main. Some projects call it main or master,
main, yeah.
but it's the master branch. So it means that it's the branch where you then from there you create the executable for your program that you're
Mhm.
going to sell, and people can download and all of that.
Mhm.
So that's where you create the images and the tags and everything. So that main is always the running code, the production code, let's say.
Yeah, but when I update, do I update main into my local branch, the Aloha branch, or when because I tried to do it this way. I tried to update the main. Tried to fetch the main and put it into my Aloha branch. That didn't work. And I was confused. And I thought, okay, I have a local branch. I update to my local. Is it my local branch or is it our local branch that all of us are using? Because I found several
Also, the
branches.
branch, yeah, the branch that everyone is common to everyone is going to be the main. That's common to everyone.
Okay, so everyone
And
has his
then when working,
private local branch.
yes.
Okay, you can name it Mickey Mouse, for example. And
Mhm.
then you push Mickey Mouse to Git. It's still Mickey Mouse, but it's not put into main. This way is only done by a pull request, right?
Yes.
Okay,
Yeah.
but if I update, what do I update? Because if you push to Goofy, and you get a pull request from Goofy into main. So in order to get yours, I need to bring main back into my local branch,
Yeah.
right?
Yeah. So it's not this one, but yeah. So I always have. I was going to open the terminal. Um, oops. What is the? Yeah. So this is the what I have in my local branch because now I've just pushed into it. So I've pushed the documents with ROS and ECAL in here, and so they are on top of main, the origin main. And once this is merged, then this is going to it's going to be like this one. So it's going to be then merged into main, and then we get main again.
Okay, yeah, it must be a mistake on my side. I guess. I need your help. Some when you have time to.
Yeah, yeah. So you see the different branches that are
Yeah.
created. So this line here is going to be the main, and you see the branches that are created on the side, and then they are merged every time. So you see here, there's these commits that are created from GitHub, which is just merging the pull requests that we have. So it's always alternate. Um, yeah, so that's basically it. In
Mhm.
theory, you could work on main and then push main, but then it would show up here as calling main, basically. Um, I never tried actually. I don't know if Git allows to push main, uh, but yeah,
Yeah, it would went around the pull request stuff.
yeah.
So it makes sense to have the pull request. Absolutely.
Hmm.
Okay, so that also means that everyone has his private branch.
Yeah.
Uh,
If maybe next time I can give also just talk about the about Git,
mhm,
because there's a lot of things that can go wrong,
mhm,
and it's good to know how to get out of it.
mhm.
But yeah.
Okay, yeah. Something is missed on my side. I could still update. That went wrong.
Hmm.
That went well, but I couldn't update to my lower branch.
Yeah.
Yeah,
So
anyhow.
yeah, but that's going to be a talk on its own.
Yeah,
There's a lot around Git, but yeah, because if you lose your branch as well, there's you can use Git ref log that shows you the history of what happened to your branch, and then you're able to see what went wrong.
and
So there's a
rollback.
lot of commands that
Mm-hmm.
that really help.
Mm-hmm. Mm-hmm.
Um, so for example, so here I can do main. So yeah, so here it shows where main was before what happened to it. And so if you lose track of your branch, you can recover and you can say, well, yeah, I want this one, and then you can do check out of this one, and then recover your work.
Yeah,
So yeah,
yeah.
there's also resets that you can do. Yeah, there's good commands in there.
Mm-hmm. I have a tool
Mhm.
for Ubuntu, a Git tool for Linux, a GUI, let's
Mm.
say, but it has so
Yeah.
many buttons.
Hmm.
It can do so many things. Jesus. Okay.
Yeah.
Yeah, I guess we need your help there. So maybe
Yeah, I
next
can
time.
do that. Just
Yeah.
yeah, go through it.
Hmm. And maybe we can next time have a little chat about how to use Git, what's the best way to use it, and so on.
Yes.
Okay. So I would say, do you have anything more to demos? Otherwise, I would stop the recording.
Yeah, I think it's for now it's everything.
Yeah.
Yeah.
Okay. Great. Thank you very much, Carlos.
Yeah, thank you.
Thank you. So I stop the recording now.